So hello friend, this is Kaustup Patharan back with a new video. Welcome to our channel Making Maths Easy. As I told you in the previous video that I am going to make a video on some important properties, the left properties in the definite integral. So this video is based on the some missing properties in the definite integral which I am going to prove in this video. So please watch the video till end, and if you are new to my channel, please subscribe my channel. So the first theorem here is integration of 2a to 0 f of x dx whose integral is equal to integral of a to 0 f of x plus f of 2a minus x dx. So let us take this first sum. We will only write the this RHS part because we are going to prove that RHS is equal to LHS. So we will take this RHS part. So first of all we will write the part as it is, and then we will split this part into the two uh, components as I1 and I2. So we will write here as a to 0 integration of a to 0 and f of x dx, again plus integration of a to 0 and f of 2a minus x. So it will be a to 0 and f of 2a minus x and dx. So we have used the property of associativity of definite integral. According to the property, we have taken the individual integration of both the terms. Now this part we will keep it as it is, and this part is equal to I1. We will write as capital I1 and plus capital I2. So, and this part is equal to I2. This part is I1 and this part is I2. So first of all we will take I2. I am taking I2. So my I2 is equal to integral of small a to 0 and f of 2a minus x dx. So this part we are going to integrate. My I2 is equal to this part, only I1 I will keep it as it is. So according to the property, I2 is equal to integral of a to 0 f of 2a minus x. So 2a can be written as a plus a, but we will not write it, and we will substitute the value for this integral. So let us substitute the values as 2a minus x equal to t, and the value of x will be equal to 2a minus t. As I have taken t on the left hand side, so it will become negative, and x on the right hand side, so it will become positive. So 2a minus t, and my dx will be equal to negative of dt, as derivative of 2a is 0 and derivative of minus t is equal to minus dt. So instead of writing this dx, we will write minus of dt, and instead of writing 2a minus x, we will write t, and afterwards we will resubstitute the value of x as x equal to 2a minus t. So instead of x we will write 2a minus t. Okay, so we will resubstitute the values and we will integrate this function with respect to t. As we are integrating it with respect to t, so the value of x in this case, when x is equal to 0, then the value of t will be equal to, after putting these values in, the x is equal to 0, the value of t will become equal to 2a, the limits. And if x equal to a, as my upper limit is a and my lower limit here is 0 in I2. Okay, in I2 I am talking about I2. Upper limit is a, lower limit is 0. So I put the lower limit as 0, then my value of t will be equal to 2a. As I am putting now upper limit equal to a, so the value of t will be equal to, means a minus 2a, so it will be equal to a. So the terms or the limits of the integration are a to 2a. So a will be my upper limit and 2a will be my lower limit. So the integral will be I2 will become equal to integration of 2a to a, or sorry, a to 2a, because a is my upper limit and 2a is my lower limit, and again f of t, because instead of 2a minus x we are putting t, so it will be f of t into minus of dt, negative dt. Okay, so this will become equal to negative integral of a to 2a, and then f of t and dt. So according to the definite integral property, as I told you, that integration of a to 2a f of x dx, or integration of a to 0 negative integration of a to 0 f of x dx is equal to integration of 0 to a f of x dx. Only the limits we have to change, that a here it will come to a, and this will become a, and this sign will go, negative sign will go, because integration of a b to a f of x means dx is equal to negative integration of a to b f of x dx. So I am writing according to the property of definite integral. I am writing here, I am not writing the property, I am directly writing it. So integration of 2a to a and f of t and dt. So finally I got the value of I2, but it is in the form of t. So according to the property of definite integral, the definite integral of any variable or any function with respect to t is corresponds to the definite integral of any function with respect to x, as it's a one of the property of definite integral. So f of t and dt can be replaced by f of x dx, because definite integral of t with respect to the values or with respect to the limits at any function is corresponds to the definite integral of x. So instead of integration of 2a to a, we can write here as integration of 2a to a, only we have to change f of t by f of x and dt by dx, so it will be f of x dx. So now I've got the values of I2. So my I1 is equal to I1 we are not going to change because we are going to prove the function. So the value of I1 is equal to f of x dx, integration of a to 0 f of x dx, and the value of I2 is equal to integration of 2a to 1 2a to a f of x dx. So my combined equation I will be equal to integral of a to 0 and f of x dx plus again this integration of 2a to a f of x dx. So now we are going to simplify this integral, as integral of f of x is equal to g of x, and we will directly put the limits as g of a minus g of 0 is my definite integral of this. So g of a minus g of 0, and again plus sign, so the integral of this function as g of 2a minus g of a, as g of a is appearing two times, as one is positive and another one is negative, so we can cancel g of a. So I'm cancelling g of a, so only the thing which is left is g of 2a minus g of 0. So g of 2a minus g of 0, as g of x is an integral of f of x, so we can resubstitute the values and we can express it in the form of integral. So it will become equal to integration of I'm again differentiating this function, means I'm again differentiating g of x, and it will become equal to f of x again in the form of integration. So the limit will be equal to 2a to 0, and then this will become equal to g of 2a, so it will be f of x and dx, which is equal to my RHS. So hence we have proved the first property or the first theorem. So let us move to the next proof. So friends, our next theorem is integration of a to minus a f of x dx, which is equal to 2 times integration of a to 0 f of x dx, and this property is only applicable when f of x means the function of x is an even function. This property is not applicable for the function of x is an odd function. If function of x is an odd function, this property is ultimately equal to 0. Means integration of a to minus a f of x dx is ultimately equal to 0. So first of all, I will take the left hand side. I'm going to prove this. I will take the left hand side, and in this means in this property I'm going to prove that this is LHS is equal to RHS. So we will use the property of definite integral first. If you don't know about this property, you can uh, watch my previous video. So this will be integration of a to minus a f of x dx equal to integration of 0 to minus a, and then f of x dx, and plus again integral definite integral of a to 0 and f of x dx. So we have done with this. So now we are going to split this sum into two parts as my I1 and I2. So capital I1 plus capital I2, which is a combination of I. So I is my integral, this f of x, and I1 and I2 are the two parts of this integral. Here I am only going to simplify the I1 part, not I2 part, because I2 part I am keeping it for the proof. So I am only going to simplify my I1 part. So my I1 part is integration of 0 to minus a 0 to minus a and f of x dx. So in this part, in this I1 part, I am going to prove it. So which will be equal to, first of all I will substitute the values for this. So put x equal to minus t, and then dx, derivative of x will be equal to minus dt, means with respect to t it will be minus of dt. And again if I put the values, the limits, when I put x equal to a, so if x is equal to a, so the value of t will be equal to, in this case uh, the value of t will be if x is equal to a, sorry, x is equal to minus a, not a. So if x is equal to minus of a, then the value of t will be equal to a, and if x equal to 0, then the value of t will be equal to 0. So the limits are from 0 to a, as 0 is my upper limit and a is my lower limit, and hence x is equal to minus t. So the value of, if I put x equal to minus a, so minus minus will become plus, and value of t will be equal to a. So my integral will become, with respect to t, it will be 0 to a, and f of t, so instead of f of x we are putting minus t, so it will be f of t and minus of dt, negative dt, so it will be minus of t, it will be f of minus t, because I am substituting minus t instead of x, so it will be f of minus t and dt, which is equal to negative of integral of 0 to a and f of minus t and dt. So this integral can be expressed as, this is a negative function, so we can write this using the definite integral property as integration of a to 0 f of minus t dt, because this is a negative, so it will become positive as I change the limits. This is one of the property of definite integral. If you don't know, you can watch my previous video on the definite integral. So it will become equal to a to 0 and f of minus t and dt, sorry, dt. So now we have done with the property. So now this a to 0 minus t dt, it is with respect to t. The integration of or definite integral of any variable with respect to t is always correspondence to with the definite integral of any variable with respect to x. So this can be written as, resubstituting the values, we can write this as uh, minus t, instead of minus t we have taken x, so we will write, and instead of dt it is dx. So it can, this can be written as this function can be written as integral of a to 0 and f of x dx. Okay, it will be f of minus x, because it is with respect to t, and with respect to x. We are not resubstituting the values. We are using the property of definite integral, that integration with respect to t is equal to integration with respect to x. So it will be minus x dx. So now we are going to uh, prove it. This is equal to I2. So I is equal to I1 plus I2. So I am writing here as I equal to I1 plus I2. So it will be equal to integration of, this is I1, so integration of a to 0 and f of minus x dx, again plus integration of a to 0 and f of x dx. So now this method is applicable only for the even number of functions. So in case of even function, what I will tell you what is an even function and odd function. If f of minus x equal to f of x, then the function is said to be an even function. Okay, and if f of x f of minus x equal to minus of f of x, then the function is said to be an odd function. Okay, if f of minus x is equal to minus of f of x, then it is an odd function. Okay, so these things you have to consider. So f of minus x can be replaced by f of x. So my integral will become equal to integration of a to 0 and f of x dx plus again integral of a to 0 and f of x dx, which is ultimately equal to 2 times the integral of a to 0 and f of x dx. So hence we have proved with the property. So let us prove the third property. So friends, our third property is based on the integration as a sum of limits. So as I told you in my previous videos, that derivative is the difference of the limits and integration is the sum of limits. As n stands for number of samples, number of samples may be ranges from 1 to infinity, as r ranges from 1 to n, means n is the number of samples. It can be 1, it can be 2, it can be 3, and so on. It can be infinity, any number. Okay, it can be a finite value or it can be an infinite value, number of samples, as my r ranges from 1 to n, and my h is the average, means b minus a divided by number of samples, which represents the average. Okay, which is denoted by my h, and a plus rh is my function. Okay, means the function of a plus rh I am going to express. So integration is expressed as a sum of limits of the two function as a plus rh into h, and whose limits of derivatives are this a and my b. Okay, for calculating the value of h, we need b minus a divided by n, and b is my upper limit and a is my lower limit in this case. So this means these values are finite. We can say integration is infinite in the case of equations, but considering these two values, value of a and b, we can say that a definite integral is always a finite, not infinite. So integration of b to a f of x dx is equal to lim of n tends to infinity summation of n to r equal to 1 and f of a plus rh multiply by h, where h denotes the average, which is expressed as b minus a divided by n. Okay, so we can express this formula as the sum of limit that ranges from b to a. So it is a finite function that ranges over from b to a as the sum of limits, as a summation symbol is given here, and the functions are a plus rh multiplied by h, and also we are finding h means height by b minus a divided by n as a number of samples. Okay, n is the number of samples. So this is expressed as a sum of limit that ranges over from b to a, and this is a finite function. Definite integral always a finite function, not the infinite function, because the value of a and b are given, the range is given. Looking at the fourth property, we can say that we have substituted the values of a and b, as my b is equal to 1 and my a is equal to 0 in this property, and if I substitute these values in this equation, I will get this as an answer. So let's substitute, as my a is equal to 0 and my b is equal to 1. So h is equal to b minus a, b minus a divided by n. So my value of b is equal to 1. So 1 minus 0 divided by n, which is ultimately equal to 1 upon n. So this 1 upon n I am going to write instead of h. So it will be equal to 1 upon n, and this h will also be equal to 1 upon n. So hence we have proved with the theorems, all the properties of the definite integral. Hope you understand the video. If you like the video, please share, subscribe and comment on my YouTube channel, Making Maths Easy. For more videos related to mathematics, engineering mathematics, 10th standard mathematics, 12th standard mathematics, please do subscribe my YouTube channel, Making Maths Easy, and please hit the bell icon. So if I upload any new video, you can get the video notification. So thank you for watching. Thank you guys.